So you might have seen the video I put on today. I don't know if I put it on or not, I don't really care, but I was on the SETI website, SETI, the Search for Extraterrestrial Intelligence website, and I was reading about how they got £36 billion investment or £1 billion investment, whatever it is, and they got this array, they made this array, and Google's co-founder or Microsoft's co-founder paid for it and what have you, and then they ran it for a while and it was a load of shit, so the government pulled their funding out of it and it almost went completely bankrupt, and some more stars from America had put some more stuff in. Her out of the film Contacts, she's raised a load of money for it to get back going again. It's going to go till about Christmas time, it might be shut down again unless NASA fund it a little bit more. And I wasn't just a bit, I was very annoyed, right? Because we've got the opportunity there to make faster than light contact, but it seems that what we're doing is we're sitting there and waiting for particles which they think come at the speed of light to hit us, and they don't even know if they're going faster than the speed of light because they're fucking arseholes. So they can't determine where they've come from at all. They've got no idea what direction they've come from because they've got no idea because they're following Einstein's laws. But anyway, by the by, so I was sitting there reading how to make a speed of light visible light telescope that can see faster than the speed of light. So the normal telescope that you look through, alright, can be anything from I think that's called a Newtonian one, and then you can get reflectors and refractors and all sorts of things like, I think Newtonian's a refractor, and you can make reflector telescopes and blah blah blah. And then you go down radio telescope, sub-millimeter telescope, infrared telescope, visible light telescope, ultraviolet telescope, X-ray telescope, far infrared telescope, and gamma ray telescopes. And I'm reading about all that because I just like reading about them. So then I'm reading about wavelengths because these are all wavelengths. I'm thinking to myself, oh, there's a wavelength here, like yeah, it's on the picometer. And then I'm reading about picometer, and I realise that the size of an atom's a picometer. On the picometer scale, like yeah, I'm going through that, and I'm thinking like, oh, is that how vitamin D is produced? So I'm starting to feel, I haven't read about vitamin D yet. I've got to go and read about vitamin D. I'll just put that to one side and thought, fuck vitamin D for a second. I want to go and fucking read about what's called, read about another time. Then I went on to atomic width, gamma ray intrusion. So then I started reading about gamma ray intrusion into the atom. So that obviously led me to nucleus, which is obviously proton and neutron, and then I started reading about cell damage, which is back to vitamin D a little bit, but it was just about movement speed. So you got the damage that's caused by gamma rays isn't to do with the speed and the movement, it's to do with its collision with the nucleus, which is basically fusion, right? And then because I was reading about the collision of gamma ray with the nucleus, that led me to protons and neutrons and reading about them a bit more. And it was also, I got led on to reading about nuclear shielding, because obviously I'm reading about all this stuff, and you go around the web reading about all this stuff, and you end up doing this, like, yeah. So I'm reading about this, yeah. So this is why mass weight is more important than materials, and materials don't make much difference, blah blah blah. You know it if you follow what I'm going on about. So I was reading about telescopes, and I was reading about gamma rays. I was reading about positrons, electron pairs. That's what we're going. I'm going to positron electron pairs. So that was called pair production. So that led me to pair production. I was reading about pair production. Now obviously there's a certain amount. There's different types of gamma ray contact with the nucleus of an atom, and one contact creates something called pair production. And pair production is where you've got one photon, gamma ray, or gamma ray photon they call it, yeah. So it's basically a photon which is on the picometer scale wavelength, and because its wavelength is so small, its oscillation, instead of being a big oscillation which prevents it from going into the cell, like the photon just bounces back off again because its oscillation's so fucking big it can't get in. Because the gamma ray has got a little oscillation, it can go straight through the atom and come out the other side. But if it contacts the centre of the atom, right, then you get, it depends which wavelength the gamma ray is at, and they're all below picometer, right? When that hits the centre of the atom, it does one of three things. One of these things is called pair production. And when it creates pair production, what it does is it creates an electron and a positron at the same time. So you get two lots of energy, a negative and a positive energy. Now if these two collide, then you get an even bigger burst of energy, right, which creates something else. Now let me just go through that for you, because this is the point that I'm getting to when I'm reading. And I'll just read about telescopes. I was reading about telescopes and trying to make a faster than light telescope, and I've ended up with coming to pair production. And I think I'm going to have to go and read about Cayley-Dixon algebras in a second again, just to polish up on the Cayley-Dixon algebras. So anyway, gamma absorption into the nucleus creates pair production. So that's one electron or photon creates two electrons. And if those two collide, the positron electron annihilation, they create two or more gamma ray photons. Now you're wondering how expansion of the universe works, and how the expansion of the universe is increasing. And then you see at the centre of every universe is a great big black hole, and every time something goes into it, doesn't matter how small it is or how big it is, it's annihilated in the black hole, and the black hole creates X-rays, gamma rays and photons. Now the X-rays and gamma rays are emitted instantly in a great big beam that you'll see when you look at a quasar feeding, and they are fed up to the top of the universe and then around the universe, the one at the centre of the universe. Or if you're in a galaxy, it's up to the top of the galaxy and then round and makes the shell. That's what makes the shell of your galaxy, or your universe, or your solar system, because it's happening in the centre of the sun as well, on a smaller scale, because we're still getting gamma rays and X-rays coming off of it, like, yeah. And that's how expansion happens. And I'm just reading about telescopes now to try and help SETI contact aliens. And then we've got this thing where SETI have got this great big array of telescopes on the ground, right? And I'm looking at wavelengths of telescopes, right? And then I've got this graph in front of me right now, and then we start at gamma rays. You like fucking lunatics, by the way. We start at gamma rays and we come down through X-rays and ultraviolet, and these are all blocked by our atmosphere. And then we get into the visible light section, where most of the visible light is not absorbed by the atmosphere, it's not blocked by the atmosphere, so our visible light telescopes can see it, but not all visible light is visible to us from in Earth's atmosphere, which means you can basically paint a ship a certain colour and not be able to see it from Earth, amazingly. But then you go from the visible light into the infrared spectrum again, back into the infrared. No, sorry, go into the infrared, sorry, because the X-rays are a bit further down here a bit again. And a lot of the infrared spectrum is absorbed, and it's better to go into space to actually see them, like, yeah, but most of it's absorbed, so you have to have space-based telescopes to see them. And then you come into the radio wave kind of wavelengths, yeah, where we can see all those. And then you go into the long wave and you can't see them. So they're completely blocked. Long waves are completely blocked. All the other ones are slightly visible, but long waves completely blocked. This is what I'm reading about, and it led me to pair production, and now on expansion of the universe. And that's what I've been getting up to tonight. What have you been doing? Shagging some butt? Have you been butt fucking? Have you been mind fragging? I've been reading about telescopes, and I ended up reading about pair production and figuring out expansion of the universe in another way. Not only is mitosis doing it, it is mitosis. that is mitosis. That's what I've been doing tonight. That's another A4 sheet of paper which I'm just going to chuck on the floor somewhere. It'll just going to be lying about. It's fun, isn't it? My lips dragging across the floor and my knuckles are ground a little bit. Knuckle scraper.